All right, so let's take 2 on this. So I kind of already got into that, so I didn't want to start all the way over again. So this is just going to be part 3 now. So we were on number 5, so we were balancing the equation, and we already did that, and we're looking for the mass of copper, and we're starting off with 12.0 grams of silver nitrate. So we wrote out 12.0 grams of silver nitrate, and now we're going to bring grams of silver nitrate on bottom next. Okay, and that's going to go to 1 mole of AgNO3. Okay, and then the mass of silver nitrate is 169.88 grams. Next, I'm going to bring moles of AgNO3 on bottom. And I'm trying to get to copper, so this is going to be my moles of copper on top. Okay, and I have 2 moles of AgNO3, and I have 1 mole of copper. Okay, lastly what I'm going to do is I'm going to bring moles of copper on bottom. And I know that 1 mole of copper equals the grams of copper on top. And copper has a mass of 63.55 grams. Okay, multiply everything on top, get a number. Multiply everything on bottom, get a number. And then divide top by bottom. And you should get 2.24 grams of copper. Number 6, for the balanced equation shown below, if the reaction of 71.2 grams of O2 produces an actual yield of 18.3, what is the percent yield of NO2? So I was given actual grams of NO2. Okay, so that's my actual. In order to do percent yield, which is actual over theoretical, I need to have theoretical. So I was given 71.2 grams of O2. Okay, and I need to find theoretically how many grams of NO2 I can get by doing a conversion. So what I'm going to do is I'm going to start with 71.2 grams of O2. Okay, and I'm going to go all the way to grams of NO2. So I'm going to start with grams of O2 on bottom. There is 31.998 grams in 1 mole of O2. Okay, I'm going to bring moles of O2 on bottom next, and I'm trying to get to NO2, so this is going to be my moles of NO2 on top. There are 4 moles of NO2, and there are 13 moles of O2. Last step, I'm going to bring moles of NO2 on bottom. And I know that 1 mole of NO2 equals the mass, which is 46.005 grams of NO2. Okay, so all I got to do is multiply everything out, divide by the bottom, and you get 31.5 grams. So that is my theoretical. So now I can take my actual, so 18.3, and divide it by my theoretical, 31.5, and multiply by 100. That's going to give me a percentage of 58%. Okay, and that's my answer. Okay, number 7, determine the theoretical yield. So you're looking for theoretical yield of zinc chloride if the actual yield is found to be 7.9 grams. So there's my actual. And the percent yield is 86%. So on this one, I have my percentage. So percentage equals actual over theoretical. So my actual is 7.9. And you can treat theoretical like X. We're just looking for theoretical, and that's what's times 100. Okay, so first thing I'm going to do is I'm going to divide both sides by 100 to get rid of that. So that's going to turn that 86% into 0.86 equals 7.9 over X. Okay, so this is the number one mistake, is that everyone wants to multiply by 7.9. Okay, that would not do anything to get my X off bottom. So what I'm actually going to show you is the trick. If you have a variable on bottom, just switch these two. Okay, so it's going to be 7.9 divided by 0.86. So that means my theoretical is actually going to be 9.2 grams. Okay, number 8. In the reaction below, iodine is shown to be a limiting reactant. So right here, so pay attention to that. Okay, I already told you what the limiting reactant is going to be. So there's no need to do 2 conversions to a product to figure out who's going to make the smallest. If there are 15.5 grams of K and 15.5 grams of I2, how much excess is left over when the remaining reaction is complete? So that means iodine is my limiting reactant, and then that means potassium is my excess reactant. So again, you don't need to do 2 conversions. Okay, since we already know who the limiting reactant is, so we're going to go from limiting to excess. Okay, so you're going to start off with your limiting. So there are 15.5 grams of I2, and I'm going to go all the way to grams of K. Okay, so grams of I2, there are 253.808 grams of I2, in 1 mole. Okay, moles of I2 goes on bottom next. Okay, this is already balanced. There's only 1 mole of I2. And I'm trying to get to K, so moles of K on top. And there are 2 moles of K. Last step is I know that 1 mole of K equals the mass of K, and I get that as 39.098 grams. Okay, so multiply it out, divide by the bottom, and I get a theoretical of 4.7, I'm sorry, a theoretical yield of 4.78 grams. So that is how many grams of K I actually used. So if I want to figure out how much is left over, I put in 15.5 grams, so 15.5 minus 4.78 gives me 10.7 grams excess. Okay, so now we're actually going to move on to the gas laws. So this might shake some rust off. So we're going to write up the equations. So we're just going to kind of write the gist of it, of what you need to know. So Boyle's law, the variables are pressure and volume. Okay, and these are an indirect relationship. So indirect means if one goes up, the other one goes down. So if pressure goes up, volume goes down. The equation for that is P1 times V1 equals P2 times V2. Okay, Charles' law is volume and temperature. This is a direct relationship, so that means if one goes up, the other one goes up. And the equation for that is V1 over T1 equals V2 over T2. Okay, then we have Guy-Lussac's law, and that is pressure and temp. And this is another direct relationship. So if one goes up, the other one goes up. So this is a P1 over T1. Okay, let me fix that. Okay, so P1 over T1 equals P2 over T2. So a good way to know who's direct and indirect is if they're a fractional form, like V1 over T1, P1 over T1, those are direct. If they're multiplying form, like Boyle's law, that is indirect. Then you have combined gas law, which is pressure, volume, and temperature. Okay, so the relationship between the variables is just the same as the previous laws. Okay, so it just depends on what you're asking it for. So my equation for that is P1 times V1 over T1 equals P2 times V2 over T2. Okay, ideal gas law. So this is when we get to use pressure, volume, moles, and temperature. Okay, so again, the variables, it just honestly depends on what you're asking for. If it's pressure and volume, it would be indirect. If it's volume and temperature, it would be direct. So it just depends on what they're asking for. The equation is PV equals nRT. Okay, Dalton's law of partial pressure. All this basically means is that individual pressures add up to total. So pretty simple. Okay, so pressure 1 plus pressure 2 plus pressure 3, etc., equals your total pressure. Okay, number 1, describe the 5 postulates of kinetic. This is KMT, means kinetic molecular theory. Okay, 1 is that gas particles do not attract or repel. Okay, so that means that they don't care about each other, so they're not going to attract or repel each other. 2 is that they are very small. So most of gases are just made up of empty space. 3, they are in constant random motion, so they're just kind of bouncing off each other, doing their own thing. 4 is that no kinetic energy is lost, so when they hit each other, they're not losing kinetic energy. Okay, and then 5 is that all gases have the same kinetic energy at a given temp. Okay, so kinetic energy is basically energy that is created, and it depends on the mass of an object and its velocity. Okay, so the more it's moving, the more kinetic energy it has, and also the bigger it has. The bigger it is, the more kinetic energy it can have. Okay, so now we actually get into equations. So the key here is just to look at what you're given. 1 is if you see temperatures in Celsius, you have to convert those to Kelvin, so remember that. So if you want Kelvin, Kelvin equals Celsius plus 273. Okay, so we'll convert those here in just a second. So I have temperature, I have volume right here of 5.0 liter cylinder, and a pressure of 4.20 atm, and I have a pressure. Okay, so this is pressure, volume, and temperature, so this is going to be your combined gas law. So P1 times V1 over T1 equals P2 times V2 over T2. Okay, so our pressure, pressure 1 is going to be in that first sentence. So our hydrogen gas at a temperature of 22 degrees Celsius that is combined in a 5.00 liter cylinder exerts a pressure of 4.20 atmospheres. If the gas is released into 10 liters, okay, so now we're changing things. So that means that first sentence was all my ones. So my pressure 1 is 4.20 atmospheres. Volume 1 is 5.00 liters. And temperature, I'm going to add 273 to that 22, and that gives me 295 Kelvin. Okay, on my next, so if the gas is released into a 10-liter reaction vessel at the temperature of 33.6 degrees Celsius, what's the new pressure? So basically, I'm looking for P2, so I'm going to leave it as P2. My volume is now 10.0 liters, and now my temperature, I'm going to add 273, and I get 306.6. Okay, so this is where you cross multiply and divide. So you're going to cross multiply here. Okay, and then you're going to divide by 295. And since there is something attached to P2, you're going to have to divide again by 10. So cross multiply, divide, divide. So pressure 2 should be 2.18 atmospheres. Okay, moving on to the next one. What is the volume of 1 mole of gas at a standard temperature and pressure? So that's what STP stands for, is just standard temperature and pressure. So 1 mole equals 22.4 liters. Okay, and standard temperature is just 273 Kelvin, and standard pressure is just 1 atmosphere. Okay, 5, if a sample of oxygen gas, O2, has a volume of 25 liters at 298 Kelvin, what's the new volume if the temperature is raised to 330 Kelvin? So I'm given volume and temperature. Okay, and I'm looking for the new volume and new temperature, and I have the new temperature. So this is going to be V1 over T1 equals V2 over T2. Okay, so volume 1, 25.0 over T1. It's already in Kelvin, so just put 298. Okay, what will be the new volume if the temperature is raised to 330 Kelvin? So I don't know V2, and T2 is 330. Okay, this is where you just simply cross multiply and then divide. So 25.0 times 330 and divided by 298. And that comes out to a volume 2 of 27.7 liters. Okay, consider 4 sealed rigid containers with the following volumes: 50 milliliters, 100 milliliters, 250 milliliters, and 500 milliliters. If each of these contains 0.25 moles of helium gas at a standard temperature, which container would have the highest pressure? So all containers have the same amount of gas in it. So pressure is going to be with the smallest container. Okay, so the smallest volume equals highest pressure. So that should make sense. The smaller the container is, the more pressure it's going to exert. Okay, so that means my 50 milliliter container is going to have the most pressure. Number 7, calculate the number of moles. So I'm looking for N, and the gas that occupies 3.5 liters, so I was given V, and a pressure of 150 kPa. Okay, so I was given pressure, and I was given a temperature of 45.6 degrees Celsius. So the only one that uses all 4 is going to be ideal gas law, which is PV equals nRT. Okay, so remember your R's, this is a constant that will give you. So atmospheres, if the pressure was in atmospheres, your R would be 0.0821. If it was in kPa, which it is, you're going to use an R value of 8.315. And then if it was like in something like torr, your value for R would be 62.4. But again, we'll give you those. So my pressure is 150. Okay, my volume is 3.45. Equals N, which I'm looking for, so I'm going to leave it as N. R is going to be 8.315 since we are in kPa. And my temperature, I'm going to add 273 to that 45.6. and that is going to be 318.6. Okay, so solve for n, so divide both sides by whatever 8.315 and 318.6 is, and you should get 0.195 moles. Okay, number 9, the pressure in a car tire is 1.758 atmospheres at 34 degrees Celsius, so I'm given pressure and temperature. What will be the new pressure if the temperature rises to 45 degrees Celsius? So I'm doing pressure and temperature, so this is going to be P1 over T1 equals P2 over T2. Okay, pressure is 1.75. Temperature, I'm going to add 273, so that gives me 307. Okay, pressure 2, I don't know, I'm going to leave as P2. And temperature 2, I'm going to add 273, and that's going to be 318. Cross multiply and divide, and you should get a pressure 2 of 1.81 atmospheres. 10, a sample of nitrogen collected in the laboratory occupies a volume of 725 milliliters at 0.971 atm. So I've given volume, and I'm given pressure. What would be the new volume with a gas occupied a pressure of 1.40 atm? So I'm doing just pressure and volume, so this is going to be P1 times V1 equals P2 times V2. Okay, so pressure 1 is 0.971. Volume 1 is 725 equals my pressure 2 is 1.40, and volume 2 I don't know, so I'm going to leave it as volume 2. Okay, so divide both sides by 1.40, and you get a volume 2 of 503 milliliters. 11, find the partial pressure of the helium gas in a container that has a total pressure of 4.74 atmospheres. So I know my total pressure, and I'm looking for the partial pressure of helium, and it also contains 1.70 atmospheres of oxygen and 0.41 atmospheres of nitrogen. So my P total is 4.74, and that's made of 1.70 atmospheres of oxygen, 0.41 atmospheres of nitrogen, and whatever the pressure of helium is. Okay, so this is just simple math, so subtract 1.70 and 0.41 from both sides, and that means the pressure of helium is going to be 2.63 atmospheres. Okay, so that should be it there. So we're going to go on to solutions. Okay, so we're going to start off with just some definitions. So we're going to start off with solute and solvent. Okay, so solute is just a substance dissolved in a solvent. So solute is the one being dissolved. So this is like something like salt. Solvent dissolves the solute. So it's the one doing the dissolving. So that would be something like water. Okay, a solution is just when you have solute dissolved in a solvent. So basically it's just a mixture. So that would be something like salt water. Okay, saturated, this is when solute is completely dissolved at the maximum possible amount. So that means at a given temperature and a certain volume, that is the max amount you can dissolve. And we'll use the graph here in a bit. Okay, so when we use that graph, that means you're going to be on the line. If you're on the line, that means you're saturated. Unsaturated means you can still have more solute added and still be dissolved. So that means you've still got room to add more, and it will still be dissolved. Okay, so this would be under the line. That is unsaturated. Supersaturated is the opposite. So that means solvent can no longer, solvent can no longer dissolve solute. Okay, so that means the solute, the more and more you just keep adding, it will just stay a solid. So solute will just stay solid. Okay, this would be above the line. Okay, molarity, that is just the concentration in a volume of solvent. So basically, how much do you have in a certain solvent? And the equation for that is big M equals moles over liters. Okay, dilution is if you add, so if adding solvent decreases concentration. Okay, so if you want to make something more diluted, you just keep adding more and more solvent. So like if you wanted like sweet tea to be less sweet, you just keep adding more and more tea to basically make it more dilute, and so you're not having as much sugar. And the equation for that would be capital M1 times V1 equals capital M2 times V2. Okay, so now we're actually getting into problems. So what is the molarity of a solution that which 62.50 grams of NaCl are dissolved in 0.500 liters of solution? So I know the equation for molarity is M equals moles over liters. I have liters, but I don't have moles. So I'm going to do a quick conversion. So 62.50 grams of NaCl. I'm going to do a one-stepper. So grams of NaCl goes on bottom. Moles goes on top. So 1 mole of NaCl equals the mass. And NaCl has a mass of 58.45 grams. So divide 62.50 by 58.45, and that's going to give you 1.07 moles. So now I know my moles. So you can take your 1.07 moles, divide it by your 0.500 liters, and I get a concentration of 2.14 M. 2, what is the molarity of a solution that contains 0.400 moles of HCl and 9.79 liters of solution? So this one I already know moles. So big M equals 0.400, that's my moles, over my liters, which is 9.79. This comes out to 0.041 M. 3, caustic soda is 20 M, so that's your concentration right here. Okay, and is diluted for household use. What is the household concentration if 10 milliliters? So I have molarity, I have volume, and I'm looking for the new concentration, so I'm looking for M2, and we are diluting to 500 milliliters, so there is your volume 2. So this would be the M1 times V1 equals M2 times V2. Okay, so M1 is going to be 20. Okay, and volume 1 was 10 milliliters. And we're looking for M2 when we changed our volume to 500 milliliters. Okay, so divide both sides by 500, so that means my concentration for M2 is 0.4 M. Okay, so you can see how by adding more and more volume, my concentration went down. Okay, number 4, a sample of 0.0255 moles of potassium hydroxide was dissolved in water to yield 10.0 milliliters of solution. What is the molarity of the solution? Okay, so I'm looking for big M, and I was given moles, and I was given liters. Well, technically not liters, I was given volume. So in order to do big M, which is moles over liters, I need to get into liters. So I'm going to change this 10.0 to liters, and 1 liter is 1,000 milliliters. So I'm going to take this 10 and divide it by 1,000, and that gives me a volume of 0.01 liters. So now I can take my moles, which is 0.0255, divide it by 0.01, and this gives me concentration of 2.55 M. 5, how much concentrated 18.0 M sulfuric acid is needed to prepare 500 milliliters of a 9.00 M solution? Okay, so I was given M1. Okay, and I'm looking for the volume 1. So volume 1 is my question mark, and my new volume is going to be 500 milliliters. So there's my V2 with a concentration. That's my M2 of 9.00. So So this is going to be the M1 times V1 equals M2 times V2. So my M1 is 18.0. And I don't know that volume, so V1 is going to stay V1. And my new concentration is 9.00. And my new volume is 500 milliliters. Okay, divide both sides by 18.0 and you get a volume 1 of 250 milliliters. Okay, so if you converted that to liters, that's fine. Okay, you just have to convert to liters in order to do this equation right here. Okay, you do not have to do liters on the M1, V1 equals M2, V2. Okay, so now we're talking about the solubility curve. So this is what I'm talking about when it's on the line, above the line, or under the line. So what is the maximum amount of potassium bromide that can be dissolved in 100 grams of water at 50 degrees Celsius in order to make saturated solution? So saturated means on the line. Okay, and this whole chart is 100 grams of water. So at 50 degrees Celsius, I'm going to find my 50 on the bottom, and I'm going to go up until I reach potassium bromide, which is KBr, which is right here. So if you look over to the left, that means I can dissolve 80 grams and be saturated. 7, would a solution that consists of 70 grams of NaClO3 dissolved in 100 grams of water at 10 degrees Celsius be saturated, unsaturated, or supersaturated? So at 10 degrees Celsius, I have 70 grams. Okay, so that's right about here. And I'm looking at the NaClO3 line, which is just right above it. So if I fall below that line, that means I'm going to be unsaturated. So that means I could still add more to that and it would still dissolve. 8, how many grams of potassium nitrate are needed to desaturate 50 grams of water? So watch out for this, 50 grams of water at 50 degrees Celsius. So at 50, okay, I'm going to go up to potassium nitrate, was the KNO3 line. So right there, about 80 again. But that's for 100 grams of water. So I want to know 50 grams of water. 50 is half of 100, so take that 80, divide it by 2, and that means I can dissolve 40 grams. 9, a saturated solution of potassium bromide is formed from 100 grams of water. If the saturated solution is cooled from 90 degrees to 10 degrees, how many grams of precipitate are formed? So how much of that dissolved substance will turn back into a solid? Okay, so we're going to find the point where we start. So at 90 degrees, I'm going to find my potassium bromide line. So that's KBr. So 90, I'm going to go up. So that is roughly about, look to the left, and that is about 100 grams. And I'm going to drop the temperature all the way to 10. So that's going to take that right about here at 60 grams. So 100 minus 60 means that 40 grams are now going to turn back into a solid. 10, if 100 grams of water at 100 degrees Celsius has 120 grams of sodium chlorate, how many grams of NaClO3 would be needed to be added to the solution for it to be saturated? So at 100 degrees, I'm going to go up to 120 grams. So 100 degrees, I'm going to go up to 120, which is right about here. Okay, and I want to figure out how many more grams can I add to sodium chlorate, which is your NaClO3 line, to make it saturated. So my NaClO3 line at 100 degrees is right about here. Okay, so that's about 200 grams if you look to the left. So I'm going to take that 200 and I'm going to subtract the 120. So that means I could still add about 80 grams and it would still dissolve and make it saturated. Okay, 11, what is the minimum temperature needed to dissolve 40 grams of KCl in 100 grams of water? Okay, so I'm looking for the temperature needed to dissolve 40 grams of KCl in 100 grams of water. So I'm going to find the 40 gram line. I'm going to follow it all the way till I hit the KCl. Okay, so that's going to roughly be about here. Okay, so if I look down, that means at 40 degrees Celsius, I could dissolve 40 grams. Okay, so you're really just reading your X's and Y's on this. Okay, now we're getting into pH, so I think we should almost be done. Okay, so we're getting to pH, concentrations, things like that. So we're going to give you these formulas so you can kind of use this. Okay, one thing to know is if you want to be an acid, your pH level has to be 1 through 7. Okay, if you're a base, your pH level is 7 to 14. Okay, so if you're perfectly on 7, that would just mean you're neutral. Okay, so we just put that there so you don't have to worry about decimals. So an aqueous solution that has a H plus concentration of 4.5 times 10 to the negative 11. Calculate the OH minus concentration, so your hydroxide concentration, your pH, and pOH of the solution. Is it acidic, basic, or neutral? So we get to do all steps. So I'm given H plus concentration, so I can go ahead and just find my pH. pH equals negative log of your concentration. So 4.5 times 10 to the negative 11. Okay, so your log button is just on your calculator, so just press negative log and type in that number, and you get a number of 10.3. So this number right here is going to tell me if I'm acidic, basic, or neutral. So if you look back over to the left, what we wrote down, 10.3 falls under a base. So this is going to answer that last question. Okay, so that is a base. So if I have my pH now, it's going to be easy to find pOH because pOH and pH, if you add them together, they equal out to 14. So pOH, all I got to do is take 14 minus 10.3, and that means my pOH is 3.7. Okay, lastly, if I want to go back, if I want to go from pOH to OH concentration, I'm going to do this opposite of log. I'm going to do second log, so you're going to press second log on your calculator. So my OH concentration is going to be second log, so it's going to look like 10 with an exponent on top, and you have to make that a negative 3.7. So second log, negative 3.7, and you get a number of 2.0 times 10 to the negative 4. Okay, so if you get a slightly different number, that's fine, because the slightest amount of rounding can change that a bit. Okay, so I did a little bit of rounding here, so if you got a different answer, that's fine, because it's such a small number, it looks like a big difference, but it's really actually not. Okay, 13. Calculate the hydrogen ion concentration for an aqueous solution of hydroxide ion with a hydroxide ion concentration of 3.56 times 10 to the negative 10. Okay, so here's another one. So if you added pH and pOH, you would get 14. Well, if you multiply your concentrations, you actually get 1 times 10 to the negative 14. So I know I'm looking for my hydrogen concentration, so I'm going to leave that as my H plus bracket. So you're going to treat that like X. And if I multiply that by my hydroxide concentration, which is 3.56 times 10 to the negative 10, it comes out to equal 1 times 10 to the negative 14. So just take 1 times 10 to the negative 14 and divide it by 3.56 times 10 to the negative 10. And I get an H plus concentration of 2.81 times 10 to the negative 5th. Okay, so if you got a different answer, just make sure you check your calculator. When you have multiple scientific notations, your calculator can get confused if you don't use parentheses. Okay, so it can get confused. You may have done their work right, but your calculator just messed it up. 14, calculate the OH concentration of a solution with a pH of 9.3. Okay, so what I'm going to do is I'm going to just go ahead and find my pOH since I know my pH. So pOH is going to equal 14 minus 9.3. That gives me 4.7. So if I want to go back, if I want to find my OH concentration, I'm going to do second log of negative 4.7. And that gives me a number of 2.00 times 10 to the negative 5th. Okay, last problem. Calculate the pH of a solution with H plus concentration of 8.4 times 10 to the negative 4. So I'm looking for pH. So pH equals negative log of 8.4 times 10 to the negative 4. Okay, so plug that in and you get an answer of 3.1. Okay, so that is it for this review. So you do get a lot of resources on this exam. Okay, so take your time on the exam. Use this video to help you out if you need to go back and see some things. You can check the key for more in depth. answers. So like on the exam, you get your periodic table, polyatomic ion lists, your molecular geometry shapes. You get the equations for doing pH, POH, things like that. You get all your gas law equations. So you do have a lot of resources there. So don't think you have to know all this off the top of your head. So there will be a lot there to help you. So hopefully this kind of helped you out and these videos kind of helped you out this year, and just let us know if you need any help.